Thank you for coming today. I'm Aiden Leitch. Some of you already know me. And so today I'm going to be talking about 3D printing, what it is, how it'll impact you, how it'll impact our world. So I want to start off by asking, when about did you first hear about 3D printing? So raise your hand if like about 1 year ago. About 2 years ago. About 3 years ago. About 4 years ago. Okay, so you can probably see the gap there between the people around 2 years ago and the people around like 4 years ago. There aren't many past about 2 years ago, and that shows that it's become really big recently. And I will explain why in a bit, but first I just want to show you some pictures of 3D printers. That is a 3D printer. 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 Can you guess what that is? Can you guess what that is? It's a toaster oven, actually. Okay. So here I have a little timeline of some like kind of big events in 3D printing. And I'm not going to go through all of them, but I'm going to start with the first one you see in 1984. That's when 3D printing was first invented. It's been around for a lot longer than people usually think. However, if you notice, not a lot happened. It was created, it was invented, it was patented, a few companies were started, and then nothing really happened until 2005. And the reason that is because after it was invented by Chuck Hull in 1984, a few companies were formed dedicated to it, and they kept it isolated to themselves and other large industries. And this did a lot of bad and not any good because it caused nothing to really happen. Not a lot of innovation took place up until recently. So, yeah, we also remember those names of Stratasys and 3D Systems. Those are still big companies today, and they'll come up in our talk later. So here's a little graphic I made of a four-way Venn diagram of what I think 3D printing really is. So as you can see, the four pillars of software, hardware, knowledge, and making awesome stuff. So you can see where they converge and what that forms and when they all converge and form 3D printing. So we see, like, for example, in between software and hardware, the physical 3D printer itself. Between making awesome stuff and knowledge, what school should be, and real-world skills. So that's just a little graphic I made, and that's basically that. Okay, so now I'm going to take you through the actual steps done by a person to operate a 3D printer and have it print something, spit something out. So there are three possible starting points with 3D printing. Design, 3D scan, or download. So with design, which is my personal choice, typically, you start off with a three-dimensional design software, which is a specialized program designed to create virtual 3D objects. These can be fully customizable as it's seen as being one of the great things about design, is that you can make it however much complicated or simple you want. You have full control over it. However, one of the difficulties is, especially for beginners, it's hard to use some softwares, and they can be a bit cumbersome and have their own little quirks. One of the other options is 3D scanning. So just how like 2D printers often have built-in document scanners where you can insert a piece of paper and have it scan it and possibly reprint it if you want. There are three-dimensional scanners, which you can use to scan a physical existing object. And then from there, you can 3D print it if you want. So this is great because you can accurately replicate existing objects. So if you need to make a fitting for something or replicate something that you don't have the design files for, you can scan it and print it. Now, this usually isn't a great and greatly feasible option because the equipment is expensive and it's limited to what already exists. You can only scan what already exists and what you have access to. So you can't go from 3D scan and 3D print and create something that doesn't exist. The other option is download. So there are many websites on the internet where you can get files to download that you can 3D print, 3D printable files. And this is great because other people design them, so you don't have to put a lot of work into it. And there are many to choose from. There's so many out there that you can download and 3D print yourself. However, the downside is unless you modify it yourself, you have no customizability over what you download. So then once you've chosen one of those three starting points, you then go on to what's called slicing. So what slicing is when you take the virtual 3D file that you got in one of those three ways and take it into a special software called a slicing software. And so what that slicing software does is it takes the 3D model and it cuts it up into really fine layers, and then it turns those layers into code, a language that the 3D printer can understand and interpret as movement in order to create the object that was just virtual. So then once it's sliced into code that the printer can understand, it can be sent to the printer and the 3D printer can print it. So here's a little time lapse of a 3D printer going. So it's sped up. Many people in the community do this as it's fun to watch the object kind of grow much more quickly. This probably took about maybe 10 hours to actually print in reality. If printers actually went this fast, everything would be a lot better. But unfortunately, this is just a sped up video. So, let that play. And it's done. So let's talk about some different methods and processes of 3D printing. So the first and most common one, this was not the first created one, but this is around now the most common type of method and process. It's called fused deposition modeling, also known as FDM. And it works by pulling in solid plastic and pushing that through a really heated nozzle and then moving that nozzle around in order to dispense the melted plastic in the right place in order to build up an object. So this hot nozzle will move around while pushing out the filament. So for example, it'll pull in the filament, push it around, make one layer, move to the next layer, make that, move to the next layer until it's done as you saw. So here's an up-close video where you can see the heated nozzle that has the filament or the plastic being pushed through and building up an object here. So some of the advantages of this process and method of 3D printing is it's very cheap. Compared to some of the other options, it's very safe, and there are a lot of materials you can use. However, despite this, it's the least precise of all 3D printing methods. And so this is not as good because it's, as I said, it's the least precise. You get the least resolution. It's the worst quality out of them, even though you can still get pretty good results at times. So the next type is stereolithography, also known as SLA. This was the first type invented, the one that was invented in 1984. And this one works quite differently in that it has a basin of a special liquid called a photopolymer. And what a photopolymer does is it turns into hard, rigid plastic when it's exposed to intense light. So how this system works is it has a basin of this liquid photopolymer, and then it has a laser that moves around and will solidify different parts of the liquid in order to build up this object in a particular way. So for example, the laser will move around, solidify one part of the liquid, it'll fill up with more liquid, it'll solidify that, fill up more, solidify that, and keep going. So here's a little video. In it, you can see the green laser there that's moving around and solidifying the different part, and it's slowly pulling up layers of plastic. So this is a great method because it's much more precise than the last one I mentioned, much more precise. However, it's messy because you're dealing with a liquid that when exposed to light will, over time, will turn into a rigid plastic, and that's usually not so good. Also, this is the slowest of all the processes. So I'm just going over 3 of the most common ones, and the third one is selective laser sintering, also known as SLS. And what SLS does is it works similarly to the last method, and this is typically the most expensive and most industrial form of 3D printing that's used. So the way this works as opposed to having a liquid photopolymer, it has a powder, and it will put down a layer of powder and then have a laser that melts the individual particles of the powder together in order to build up one layer at a time. So this allows for the highest precision of any 3D printing technology, process, method, whatever you want to call it. And it allows for a wide range of materials too, because if it can be in a powdered form that can be melted by a high power laser, then it can be used. So here's a small clip of it. So as you can see, the roller is about to come in and put over another layer of this powdered plastic. And then the laser is going to come back and make another layer in that powder, as we can see. And so it moves around, and that laser is solidifying the individual particles together. It's like a CO2 laser. And so as you can see, the layer is starting to form through this powder being melted in a few places. So this is the most expensive too, as I said. It's very industrial. However, that brings up the matter of precision. And right here, you can see it later when you come down. I have a print that was made on an SLS machine. As you can see, you can't see any, well, you can see it right now, but you can't see the layers on this. On all these, which were printed on my machine, which is FDM, where it pulls in the plastic and melts it, you can visibly see the layers and feel them. On this, you can't feel them or see them. So there are also a few other methods, like binder jetting, which allows for full color printing, or polyjet, which allows for up to 81 different materials in one print. So I always get asked this: what's inside a 3D print? Is it hollow? Is it solid? Is it filled with a magical gas? No, it's usually just like a structure similarly to this hexagonal over here or rectangular over here. I have a little block here of a unfinished print where you can see what it looks like on the inside. Okay, so what materials can a 3D printer use? I mentioned in a few of the different processes they use different materials, and that allows for like different like outcomes of a print, what its qualities are, what its texture's like, what can be done to it, what kind of force it can take. So let's start with the most common one, PLA. PLA stands for polylactic acid, and it's a common plastic. It's biodegradable, it's non-toxic, and it's commonly printed with on machines like this that use FDM of pulling in plastic and melting it. There's also a different type of plastic that's similar. It's called ABS. It's more strong, more durable. However, when you print with it, it puts out toxic fumes, and it's difficult to print with in general. There's also nylon. So nylon is also often printed on machines like this that use FDM. There are lots of varieties of nylon plastic that can be printed with. Some are very elastic and flexible, or some are more rigid and strong. So there's a wide variety of different nylons you can use in 3D printing. Aluminum. So obviously you cannot print aluminum on a machine like this. You'd have to use an SLS machine that lays down aluminum powder and then melts that with a laser. Carbon fiber. There are even 3D printers like this that use this kind of process that pull in and push out carbon strands and then weave those together in order to create carbon fiber. And that can be embedded in plastic parts to make them much, much stronger. So there's also a subcategory of 3D printer materials called composite materials. And what these are is normal plastics like the PLA or ABS that I mentioned, just filled with another kind of compound, whether that's wood fibers or shards of crystals or brick or something else. So for example, bamboo fibers can be put in this, and that allows, or any wood fiber, for example, can be put in the plastic to make it sandable, and you can apply a stain to it. When it's printing, it even smells like wood. So that can allow for a lot of different things. Another example of a composite material is plastic with different metals in them. This allows them to rust, to be polished, and to have a really cool effect and look like they were casted metal, not something that's plastic and came out of a 3D printer. Pizza. I think we can all agree that this is by far the best. So how this works is similarly to the one where it pushes out plastic, just instead of heating it, it just pushes out dough, pushes out tomato sauce, and then that can be applied to a lot of different food printing techniques. More food stuff, of course. So sugar can also be printed in to make custom sugar cubes or whatever you want to do. And that can work by laying down a layer of sugar and then lasering it together, just like the method I mentioned earlier. Chocolate. It can be printed both by pushing out melted chocolate or by just laying down layers of powdered chocolate and melting that together. As you can see, I put a lot of the food stuff in here. Yep. So also, this is similar to the pizza one. It can push out pasta. All right, back to actual materials. So brass is another one, similar to aluminum. Brass powder can be laid down and then melted together with a laser to create brass objects. So fabric. Researchers at Disney Innovation Labs created a type of 3D printer that cuts fabric, lays it on top of other layers of fabric, and then sews them together in order to create three-dimensional objects out of fabric. Now, this comes at the cost of precision in this case, and probably will never come to market as this technology. So, a full-color plastics. So, as I mentioned, one of the other technologies, binder jetting, that I didn't really delve into too much, can make full-color objects, and that's really cool. However, this is a very expensive process to do, and the objects aren't that strong. Concrete. So I'll talk more about this later, but there's a company in China that they're a construction firm that uses giant, massive 3D printers that are larger than buildings to print the full foundation and structure for a building in under a day. So that's revolutionary compared to modern day construction techniques when compared to that. So it works similarly by just pushing out just uncured concrete. and building up layers of that. So, rubber-like materials. So this is another actually composite material. And what this is normal plastic mixed with pieces of rubber. So I have some examples of this that you can come by and touch. For example, I can scrunch this up. It'll pop back to its original shape. Whereas this normal plastic is hard, rigid, won't bend. So then actual rubber. Some industrial printers can actually print in silicone rubbers, like neoprene rubbers, similar materials that have much more flexibility, much more strength than, for example, what I was just showing. Stuff that dissolves. So some plastics, if you put them in a liquid once they're done printing, will dissolve, just disappear away into that liquid. So oftentimes it's a solvent, but there are even materials that if you just dunk them in water, they'll just dissipate, they'll dissolve. And then biomaterials. So I'll talk about this later. So this is really interesting, really revolutionary, and is kind of big in the science community right now, of printing with biological materials, cells, your skin, anything that's a biological material that can be incorporated into a living thing. And there are many, many other types of materials, infinitely many combinations of like some composite or something like that. So something else I want to touch on is multi-material printing. And this is whether it's just printing with a few different colors at once to create a cool effect, or multiple materials for a purpose like you see here. It's just combining multi-materials, multiple colors, multiple plastics, multiple materials at once to create a 3D print. So as you can see on this one, on the left here, the white part, that's rigid, solid plastic. However, the red part, that's flexible, rubbery plastic, like what I showed there. So that allows for like a flexible hinge that's manufactured in one step. Okay, so now I'm going to talk about what can be made with 3D printer. There's so many things, so I'm just going to touch on a few. So prosthetics. This is really big because this helps out a lot of people and even some animals too, as you can see there. So what you see here is the product of the eNable project. And what the eNable project is a kind of organization to provide 3D printed, cheap, inexpensive, well-working prosthetics to people who were maybe born without hands or lost them somehow. And so they're much cheaper than ordinary prosthetics, which can cost upwards of $1,000 just for a simple hand. These cost about $15 to make each. Then on the upper right, you can see Buttercup the duck. He's a duck that was born without his left leg, and they 3D printed him a rubber prosthetic that allows him to walk. You can also see Derby the dog there. He was born with deformed legs. They 3D printed him prosthetics that allow him to run. Food. I mentioned this before. A lot can be printed with food, especially with the various different materials that can be printed. Shoes. So whether it's just something cool like that triangular pattern there with those shoes, or it's a Nike who's actually developing a 3D printer designed to 3D print shoes and 3D print onto shoes. Or whether it's just these orange shoes down here, which were just developed by someone who does this who does 3D printing on his own time and does this as a hobby and just wanted to create a pair of shoes that print in one piece per shoe. Really interesting stuff. Also, cars. So about a year ago, actually almost exactly a year ago, a company called Local Motors unveiled this car right here called the Stratty. It's a car that's 50% 3D printed. Now, none of the really working moving parts are 3D printed. It's mostly just the frame and body and parts of the car that don't really serve any like driving function. However, it cut down the amount of parts in a car, which cars usually have around 30,000 parts. This car only has 500, and that's due to 3D printing. most of the body of it. So that makes it a lot cheaper, a lot easier to make, a lot more accessible, and just a better car overall. Then to the right, you can see a car that's called the Irby. And so what it's meant to be is an urban transportation vehicle. It's electric, it's solar powered, and about 70% of it is 3D printed. Most of them metal 3D printed parts, which is really interesting. So right now, most of these aren't the most practical as of yet, but that'll probably change in the next few years. So houses. I mentioned printing in concrete. So I mentioned how that Chinese company, as you can see, has massive printers that they can just wheel into a location and have print the full structure for a building in under a day. So as you can see, a cross section of a wall right there. And due to this process, it's a lot faster, as I said, cheaper, and easier. Easier because a machine's doing it. It's not workers pouring in concrete into like built temporary molds for a wall. Instead, this machine can just build up semi-hollow walls. So that saves a lot of cost because most of it is hollow instead of being completely filled. So that saves a lot of money and can even make it stronger in some sense. So even useful household items. So even on with consumers, they can find great use for 3D printing. For example, on the left here, that's a compost grinder. That's completely 3D printed. All the parts can be printed on an ordinary 3D printer, almost any. And it can be used to grind up food bits or whatnot to create compost. To the right, you can see a toothpaste squeezer. So you can print that. It takes 25 minutes to print. I've made them myself. You can just put them on a toothpaste tube and push it forward, and it will like leave no traces of toothpaste behind in the tube. Clear it, save money, I guess, in the end. And then organs. I talked about bioprinting. So lots of researchers, many scientists and researchers and engineers have been working on printing in biological materials. What you're looking right here is a rat's kidney that was artificially created in a lab using 3D printing. So how that works is they have a specialized printer, obviously, where they replicate the cells that they need to print in, and then they extrude that out of a syringe in order to build up this organ or any biological structure in layers. And so this is a working rat's kidney. This was a few months back. It's still in its early stages. So this has a lot of potential that has not been tapped yet. And many more things. As I said, there are infinite possibilities of things you can make with a 3D printer. I've got so many things over here. You can see all of those later when you come down here. All right. So 3D printing has taken a path over the years. And as you saw in the timeline, it started with these big companies keeping it to themselves, only like licensing it out to other large companies, and it really wasn't practical in that sense. But recently, in the past like 10 years, makers and hobbyists, people who just like to make stuff on their free time, have adopted 3D printing, and they're the reason that 3D printing has become so huge recently. So I'll explain that in a moment, but after the makers and hobbyists, it's going somewhere next, and I'll talk about that after I talk about these previous two more in depth. But 3D printing has its rightful place in business. It's very useful. Here are some examples. Prototyping. So let's say you're an engineer and you need to present an idea to a meeting. What's better? Having just some papers and drawings and a screen with your design on it, or having a physical, tangible object that you can pass around to everyone at the meeting, show them what you're talking about, have them be able to literally feel what you're talking about, what your design is, as opposed to just having a piece of paper or some screens with your design on it. It's so much better to be able to 3D print a business proposal or something like that. Also, 3D printing is much faster for prototyping. Normally in prototyping, you need to have a design, then send it out to a manufacturing house. They'll injection mold it and then send it back to you after like 4 weeks pass. And that's only one prototype. With a 3D printer, you can prototype up many prototypes within just a day. That's a dramatic increase in the prototyping cycle that allows for much larger efficiency in, for example, engineering fields and some of the other fields I'll talk about in a moment. So then, in manufacturing, 3D printing is still much more efficient. So lots of people say that, oh, 3D printing is so slow, it takes like a few hours just to make a small object. Well, truth be told, it's actually a lot faster than other traditional manufacturing methods. So with injection molding, for example, you'd have to find a warehouse that'll accept your designs. They need to verify that a mold can be made for it. They need to tool the mold and then mold it and then do an injection run, and then after that, it can finally be made. But first, with 3D printing, it can be so much faster. Printers that print metal can make metal parts within a day, and they can be cheaper because 3D printing is often cheaper. As I said, the objects often aren't solidly filled. They aren't completely solid objects. This allows dramatic cost savings because most parts don't need to be completely solid material. And then also, you have more control. In this picture on the right over here, you see one part on the upper part is much more basic, much more simplistically designed and made. And then below it, you see a part that was made with 3D printing. The 3D printed one is much better. It allows much more control. It's a lighter part. It's a more cost-efficient part. It's a faster made part, as I mentioned. And they can add so much more detail that just wouldn't be possible with normal manufacturing methods. So then also, for just 3D printing a final product, so you can 3D print something and then have a tooling operation done on it, have parts of it cut and refined and made better. Or you could print a mold and then mold that, or you could print just core and then have it casted around it and recreate the object that was just 3D printed. Or just not even any post-processing at all. Just right as it's off the printer, boom, done product, or close to that. So a great example is Google's Project Aura. Maybe you've heard of this. So this is Google's idea for making a modular phone that has magnetic little blocks that you can snap into place that add different components in and out of a phone. So their idea is to have a 3D printer make all the backplates, because as you see, the backplates for each individual modules here are tons of different colors. They're all colorful, they're all cool and stuff. And that allows for better customizability. As I said, you can have a lot of different options. And so the plan is, right after these backplates are done printing, they can be put onto the module and used. So I mentioned some different fields of use that can for 3D printing. So a big one is architecture. I gave that example of like an engineer or like an architect, for example. It's better to have a 3D printed model of your final plan than to just have lots of papers and lots of different slides of examples and drawings and sketches and 3D designs of it. It's better to have a physical, tangible object that you can see, feel, and look at how it will physically be. Maybe on a scaled down use case, but still. Also, fashion, as you can see in that picture. Then aerospace engineering. This is really big. So about a year ago, NASA sent up a 3D printer to the International Space Station. And previously, before they had a 3D printer up there, if they needed a specific part, if they needed a little plastic replacement, they would need to get headquarters to find it, make it, or send them up a new one, and then they'd need to wait for another rocket to come up to the ISS and drop it off for them, and that could take up to months. Now with a 3D printer up on the International Space Station, if they need a replacement part, if they need something, they can make it in a few hours. That's a dramatic increase in speed. So I mentioned makers and hobbyists. So the maker movement and the maker community has become really big recently in the past few years. And that's kind of a result of 3D printing. And 3D printing having such big success is kind of a result of the makers and hobbyists. And so makers and hobbyists simply are people who just like to make stuff on their free time, who like to use tools to make stuff as opposed to just buying something. They can make it themselves. So something a lot of hobbyists do, and I've even done before, is quadcopters. So these are RC like kind of helicopters of sorts, and often they have 3D printed parts because the advantage here is you can make custom landing gear or a custom body as you see here for this quadcopter, because you can have these custom 3D printed parts that can be easily made with a hobbyist level 3D printer. Robotics. So this is a really big one. Robotics was usually, before 3D printing was accessible, it was like little kits, except you couldn't do much more than what was in the kit, except 3D printing has opened up so many doors for possibilities in robotics. Over here on the left, you see this humanoid robot. That's part of the InMove project. And what that is to create open source 3D printed robots. Most of that robot is 3D printed, aside from some metal parts and the electronics and motors and whatnot. Over on the right, you see a new type of robotics that's become really big recently, especially due to 3D printing. It would not be possible without 3D printing. What you see there is what's called a soft robot. And what that is a robot that's made from soft materials that doesn't use rigid, hard-moving parts. So for example, 3D printers can make a mold for a soft robot that can mold it out of rubber and make a soft robot that moves and does actions based on its internal geometry and other forces. So example, right here, I have this little device, and when I inflate it, you might be able to see it bends. And that's only because of the air pressure I'm putting on it and the internal geometry of it. And so that's a big field that's only possible because of 3D printing. Art. Many people like to just make cool things that look cool. So for example, this was something a Dutch designer did where he found brick walls with little parts that were chipped off, and then he 3D printed little parts that would fit on and make it look like the inside is made of like Lego bricks. Kind of cool. And then the RepRap project. So back on the timeline in 2005, there was a spot on that timeline that mentioned that the RepRap project was started. The RepRap project was started, as I mentioned, in 2005 by Professor Adrian Bauer, who was a professor at a university in the UK. And what the RepRap project is to create cheap, open source, easily buildable 3D printers. However, the name comes from Replicating Rapid Prototyping Machine. And what that means is basically a 3D printer that can 3D print parts for itself or to make another 3D printer. So everyone always says like, oh, 3D printer, 3D printer, 3D printer, 3D printer. So that is possible to a degree by 3D printing many parts. Now, obviously, you can't make the electronics, you can't make screws and fittings and wires and stuff, but a lot of it can be made by a 3D printer. So I mentioned open source a few times, and what open source means is anyone free of charge can access the files and documentation and information to create their own. So if you wanted to make a RepRap, you could just go on their website, find the files for one, get all the parts and make it. You don't need to pay for a license to make it. There are no patents, no copyright, no trademark. Now, if the thing I mentioned about patents earlier and how they withheld 3D printing from advancing for all those years, this is a great example. No patents, and this has caused so much innovation that this is what kicked 3D printing into the spotlight of the world. This is what's made it big so much recently, is because anybody can access files for a 3D printer, can make their own, can modify their own, can make it better, can improve upon it, and just innovate. And since everyone is publishing their work and making it easy for others to replicate, it causes so much innovation that's why 3D printing has become really big in the past few years. That's why so many of you said like you'd only heard about it like about 2 years ago. Okay, so then I also mentioned that little question mark there and where 3D printing is heading next, and that's consumers. You guys, mostly. So you're probably thinking, how can I use 3D printing? And you're probably thinking, like, I don't have a lot of use for it. Well, there's actually a lot of uses for it that you'll find in your everyday life. Having a 3D printer, I see these every single day of situations where I can apply 3D printing to better increase my efficiency in day-to-day working or just doing anything and making life easier using 3D printing. A great example is household repairs or making useful items like that compost grinder that I mentioned earlier. These are all useful items that most people don't think of until they have a 3D printer and they see the possibilities of how they can use it and how it can impact their life, how they can use it every day to make their life easier and better. So then another big thing is learning. So not only learning how to use a 3D printer, not only does that teach a lot, also it can help teach a lot of other things. For example, you can visualize equations by 3D printing a geometric model of them. You can learn about electronics and engineering. You can learn about architecture and structurality. In science, you can 3D print models that show molecules or something. And speaking on that topic of science, I have an interesting story regarding some things that I made. So I mentioned open source and how everyone can be publishing their own work and everyone can be iterating on it, everyone can find it themselves and recreate it. So over here I have 2 DNA helix molecules. I originally made this 2 years ago for my science class. However, I published those online, open source, so anyone could download them, modify them, recreate them themselves if they wanted to. And a few months after I published it, I got an email from a guy who was a teacher at a school for the blind. And what he told me is he was using my designs, what I had created just for my science classroom and to help myself learn, to help teach blind kids who couldn't see a visual model on a board or something. They would have to feel it themselves. And he said he 3D printed my designs and it helped them learn so much better than whether it's describing it, and for so much cheaper than if they had to find an educational supplier and order it from them. And that wouldn't have been possible if, not for 3D printing obviously, and it wouldn't have been possible if I hadn't published it open source for anyone to download, anyone to use, anyone to modify, anyone to 3D print. All right, so thank you for being a great audience. You can find me on basically anything on the internet by the name of XYZ Aiden. As I said, thank you for being a great audience. On your way out, if you want to come look at some 3D prints, feel welcome to. If you want to look at the printer itself, you can.